Okay, let's look into question number 31. You are a part of a cloud DevOps team managing thousands of compute instances running in Oracle Cloud Infrastructure. The OCI logging service is configured to collect logs from this instance using a unified monitoring agent. A requirement has been created to achieve logging data into OCI object storage. What OCI capability can help you to achieve this requirement? Okay, let's look into the options. Option A, Object Collection Rule. Object collection rules is not a valid OCI feature for archiving logs to object storage. So option A not a good answer. Moving on to option number B, IAM policy. IAM policies control access but do not perform log archiving or data movement. So option B not a good answer. Moving on to option number C, Service Connector Hub. Service Connector Hub enables automatic transfer of logs from OCI logging to object storage for archiving. So option C looking a good answer. Moving on to option number D, logging query. Logging query is used for searching and analyzing logs, not archiving them to object storage. So option D again a wrong choice. So option C will be the correct choice. Okay, let's look into question number 32. How does the Oracle Cloud Infrastructure Container Engine for Kubernetes cluster autoscaler determine when to create a new nodes for OKE clusters? Okay, let's look into the options. Option E, when the rate of the request to application crosses a configured threshold. Cluster autoscaler does not monitor application level request rates for scaling detection. So option A not a good answer. Moving on to option number B, when the GPU or memory utilization crosses the configuration threshold. Autoscaler react to pod scheduling failures due to resource request, not node utilization. So option B again a wrong choice. Moving on to option number C, when the custom metric from the service exceed the configuration threshold. Custom metrics are used by horizontal pod autoscaler, not cluster autoscaler. So option C again a wrong choice. Moving on to option number D, when the resource request from pod exceed the configured threshold. Cluster autoscaler adds nodes when pods cannot be scheduled due to insufficient request. So option D will be the correct choice. Okay, let's look into question number 33. How can you run application on GPU worker nodes in cluster created using container engine for Kubernetes? Okay, let's look into the options. By selecting a managed node pool, a GPU shape and a GPU image that has CUDA library pre-installed and specify the number of G required in the pod specs. Hoki supports GPU workloads by using managed node pools with GPU shapes and pre-installed CUD libraries and specify GPU counts in pod section. So option A looking a good answer. Moving on to option number B. By selecting a virtual node pool, a GPU shape and a GPU image and ensuring the CUDA libraries are included in the application container. CUDA library should be pre-installed on the node image, not bundled inside the application container. So option B not a good answer. Moving on to option number C. By selecting a managed node pool, a GPU shape and a GPU image and specify the number of GPU resources in the pod specs. GPU workloads require GPU resources application, not GPU only allocations. So option C again a wrong choice. Moving on to option number B. By selecting a managed node pools, a GPU shape and a GPU image and ensuring that the CUDA libraries for different GPUs are pre-installed on the workers nodes. Node comes with compatible CUD libraries. Applications are isolated from GPU types and does not need any version pre-installed. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 34. You host a microservices based application on the Oracle Cloud Infrastructure Container Engine for Kubernetes. Due to increased popularity of your application, you need to provision more resources to meet the growth demand. Which two statements are true for the given scenarios? Okay, let's look into the options. Create a second OKE cluster and scale the application across it. Scaling across the cluster adds complexity and it's not required unless facing multi-region or isolation needs. So option A, it's not a good answer. Moving on to option number B, enable cluster autoscaling by autoscaling node pools by deploying Kubernetes metric service server and using Kubernetes vertical pod autoscaler to resource request and limits. Cluster autoscaler and virtual pod autoscaler together allow dynamic scaling based on resource demand. So option B looking a good answer. Moving on to option number C. Scale a node pool up and down to change the number of worker nodes in the node pool and the availability domain and subnets in which to place them. Node pools can be scaled by adjusting node counts and placement across ADs and subnets. So option C looking a good answer too. Moving on to option number D. Scale a cluster up and down by changing the number of node in the pools in the cluster. Adding node pools provides diversity, not direct scaling. Scaling is done while node pools. So option D, it's not a good answer. So option B and C will be the correct choice. Okay, let's look into question number 35. As a DevOps engineer, you are tasked with streamlining the build process of your web application and decide to eliminate a specific testing stage from a build pipeline. What happened to the associated resources when the stage is removed? Okay, let's look into the options. Option A. The associated resources are marked for deletion, but they are not deleted until manually removed. OCI DevOps does not retain resources for manual detection once the stage is removed. So option A not a good answer. Moving on to option number B. The associated resources are still available but the stage is marked for deletion. Deleting a stage removes both the stage and its associated resources. So option B again a wrong choice. Moving on to option number C. The associated resources are removed but the stage itself remains available. Removing a stage also deletes the stage itself alongside its associated resources. So option C again a wrong choice. Moving on to option number D. Both the associated resources and the stage are completely removed from the build pipeline. Deleting a build pipeline stage in OCI DevOps permanently removes both the stages and its associated resources. So option B will be the correct choice. Okay, let's look into question number 36. A small company is moving to a DevOps framework to better accommodate their intermittent workloads. Which of the dynamic and irregular they want to adopt a consumption-based pricing model? Which Oracle Cloud Infrastructure Services can be used as a target deployment environments? Okay, let's look into the options. Option A functions. Oracle Function is serverless and ideal for dynamic workloads with pay per using pricing. So option A looking a good answer. Okay, let's keep it. Moving on to option number B. Bare metal compute instance. Bare metal compute instances are provisional, continuousing and built regardless of usage. So option B it's not a good answer. Moving on to option number C. Oracle Kubernetes. Oracle OCI cluster requires persistent node pools which incur cost when it's idle. So option C again a wrong choice. Moving on to option number D. Virtual machine compute instance. Virtual machine instances are built per hour or month, not based on actual innovation or usage. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 37. You are using Oracle Cloud Infrastructure DevOps to automate your application deployment for frequent release. In your automation steps, you will create a deployment pipeline. What does the deployment pipeline do in your OCI DevOps? Okay, let's look into the options. It takes a commit ID from your source code repositories and use the source code to run your build instruction. Using a commit ID to run build instruction describe a build pipeline, not a deployment pipeline. So option A is not a good answer. Moving on to option number B. It is a set of stages for your build process for building, testing and compiling software artifacts. A build pipeline handles stages for compiling and testing code, not for deployment artifacts. So option B again a wrong choice. Moving on to option number C. It is used to store, manage, develop source code with OCI DevOps code repositories. Code repositories are separate components, not a part of a deployment pipeline. So option C again a wrong choice. Moving on to option number D. It is a sequence of steps for delivering or deployment your artifacts to your target environment. Deployment pipeline automates delivery to build artifacts to target environments like OKI or compute instance. So, question number 37 answer will be option number D. Okay, let's look into question number 38. You are using the Oracle Cloud Infrastructure DevOps service and you have successfully built and tested your software application in your build pipeline. The resulting output needs to be stored in container repositories. Which stage should be you add next to your build pipeline? Okay, let's look into the options. Export package. Export package is not a valid stage in OCI DevOps or storing build outputs in container repositories. So option A, it's not a good answer. Moving on to option number B, trigger deployment. Trigger deployment initiates artifact delivery to environment not storage in a container repositories. So option B again a wrong choice. Moving on to option number C, delivery artifacts. Deliver artifact stage pushes build output to a container or artifact repositories for storage and deployments. So option C, it's not looking a good answer. Moving on to option number D, manage build. Manage build stage is used for compiling and testing, not for storing or delivering artifacts. So option D, it's a not a good answer. So option C will be the correct one. Okay, let's look into question number 39. Your company is working on high profile project and any code pushed to production requires approval. Your company is using Oracle Cloud Infrastructure DevOps service for automating the process. You want to push an artifact to production and would like to add approvers to the approval workflow in the development pipeline. How can you add approvers? Okay, let's look into the options. Option A, add approvers to the deployment pipeline and give them access via OCIM IAM policy. OCI DevOps uses IAM policies and policies are authorized using approvers in the approval stage of deployment pipelines. So option A looking a good answer. Moving on to option number B, add approvers to the build specs file before pushing the code to the OCI core repositories. The build-up specs file defines build instruction, not deployment approvals. So option B not a good answer. Moving on to option number C. Email approvers before you run the deployment pipeline. Manual emails are not part of OCI DevOps automation or approval workflows. So option C again a wrong choice. Moving on to option number D. Manual and approvers names and email address in the deployment pipeline page. Approvers are assigned via IAM groups and policies, not entering personal details in the pipeline page. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 40. As a DevOps engineer working on containerizing a microservices based application to the hosted on OCI cloud platforms, which step can help ensure that the container images have not been modified after being pushed to Oracle Cloud Infrastructure Registry? Okay, let's look into the option. Option A, enable scanning of container images stored in OCI registry. Image scanning detects vulnerabilities, not unauthorized modification after the image is pushed. So option A not a good answer. Moving on to option number B, scanning the image upon ingestion and comparing the image size for changes. Comparing image size does not reliably detect tempering or ensure image integrity. So option B again a wrong choice. Moving on to option number C, signing the image using the container registry CLI and creating an image signature that associate the image with the master encryption key and key version in the vault service. Signing the image in the container registry CLI and vault keys ensure its integrity and authenticity after being pushed. So option C looking a good answer. Let's keep it. Moving on to option number D, deploying and manifest to the Kubernetes clusters that refers the container's images and its unique hash. Referring an image hash is in Kubernetes manifest ensure immutability but does not verify post-push integrity. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 41. As a DevOps engineer working on a CI/CD pipeline For a company application, you have complete code analysis, image scanning, and automated testing. What is the next step to ensure a secure and reliable deployment? Okay, let's look into the options. Add a shell stage to run custom commands in the deployment pipeline. A shell stage executes custom commands but does not provide deployment approval or enhance security. So option A not a good answer. Moving on to option number B. Add a traffic shift stage to route the traffic between two sets of backend IPs. Traffic shift stages manages routing backends but does not ensure deployment security or approval. So option B again a wrong choice. Moving on to option number C. Add an invoke function stage to run code or custom logic in a serverless manner. Invoking a function runs custom logic but does not contribute to deployment approval or security validation. So option C again a wrong choice. Moving on to option number D. Add an approval stage to pause the deployment for a specified duration, port manual decision from the approvers. Approval stages introduce a manual checkpoint to ensure secure and authorized deployment before proceeding. So option D will be the correct one. Okay, let's look into question number 42. As an engineer building the deploying application using an OCI DevOps project, which action can help ensure the security and reliability of the code in the build and deployment pipelines? Okay, let's look into the options. Using third-party tools like Ansible, Terraform, or DevOps to analyze code for security defects or bugs in code qualities. Tools like Ansible and Terraform manage infrastructure, not code security analysis within CI/CD pipelines. So option A not a good answer. Moving on to option number B. Using version control loops tools like Git or SVN to track and manage changes in the code base. Version control tools manage code history and collaboration but do not access security or reliability in pipelines. So option B again a wrong choice. Moving on to option number. Use application dependency management to identify security weakness in software application or by checking their dependency. Application dependency management identifies vulnerabilities in third-party libraries, enhancing core security in the pipeline. So option C looking a good answer. Moving on to option number D. Use Jira to track user stories and bug fixes in the development process. Jira supports project tracking but does not directly enhance code security or reliability in the pipelines. So option D again a wrong choice. So option C will be the correct one. Okay, let's look into question number 43. The Kubernetes Masters node serves as a central code plane for managing the cluster's resources and orchestrating workload deployment. What is the primary responsibility of the Kubernetes Masters nodes? Okay, let's look into the option. Option A. The Masters node oversees the scheduling and allocating of cluster resources, ensuring optimal utilization across nodes. The master nodes manage pod scheduling and cluster state through components like scheduler and controller managers. So option A looking a good answer. Moving on to option number B. The master node monitors network traffic within the clusters, ensuring secure communication and efficient data transfer between nodes. Network traffic monitoring is handled by network plugins and policies, not by master nodes itself. So option B again a wrong choice. Moving on to option number C. The master node is primarily tasked with executing application workloads and ensuring their availability within the clusters. Application workloads run on workers node, not master nodes. So option C again a wrong choice. Moving on to option number D. The master node services as a repository for storing container images, facilitating rapid deployment and scaling for applications. Container images are stored in registries like OCI registry, not in master nodes. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 44. How can you scale a deployment name node.js deployment to have two replicas? Okay, let's look into the options. Option A, kubectl adjust deployment node.js deployments slash replicas 2. Adjust is not a recognized kubenet command. So option A not looking a good answer. Moving on to option number B. Cube select scale deployment Node.js deployment replicas is equal to 2. Kubelet scale is not a valid command to adjust the number of replicas in Kubernetes deployments. So option B looking a good answer. Moving on to option number C. Kubelet resize deployment Node.js deployment replicas 2. Resize is not a valid kubelet verb for deployment. So option C not a good answer. Moving on to option number D. Cube select set replicas deployment Node.js deployments is equal to replica is equal to 2. Set replicas is not supported in syntax for scaling deployment. So option D again a wrong choice. So option B will be the correct one. Okay, let's look into question number 45. As a DevOps engineer, you are tasked with securely storing and versioning your application source code in automatical build, test, and deploy your application to Oracle Cloud Infrastructure platforms. You are told to automate manual tasks and help software teams in managing complex environments at scale. Which three OCI services can you choose to accomplish this task? Okay, let's look into the options. Option A, Oracle Cloud Logging Analysis. Logging analysis supports observability and troubleshooting, not CI/CD automation or source code management. So option A not looking a good answer. Moving on to option number B, Container Engineering for Kubernetes. Container engines for Kubernetes orchestrate and scales containerizing application across OCI infrastructures. So option B looking a good answer. Moving on to option number C, Oracle Cloud Infrastructure Registry. OCI registry securely stores and version containers images use in automated deployment pipeline. So option C looking a good answer. Let's keep it. Moving on to option number D, DevOps project. OCI DevOps project enables automated build, test, and deployment workflows for secure and scalable application delivery. So option B, C, and D will be the correct one. Okay, let's look into question number 46. In Kubernetes clusters created by Container Engine for Kubernetes, how the data in etcd encrypted at rest by default. Okay, let's look into the options. Oracle encrypts data using the master encryption key in its managers. By default, Oracle encrypts ECD data at rest using a master encryption key its managers. So option A looking a good answer. Moving on to option number B. Data is stored without encryption. OCI encrypt block volumes by default, including etc data and Oracle encryptions. So option B not a good answer. Moving on to option number C. Data is encrypted using TLS. TLS encryption data in transmit, not at rest. So option C again a wrong choice. Moving on to option number D. User must manage their own encryption key. Key management is optional. Oracle handles it by default. So option D again a wrong choice. So option A will be the correct one. Okay, let's look into question number 47. Pods running in Oracle Container Engine for Kubernetes cluster often needs to communicate with other pods in the clusters or with service outside the cluster. As the OKI cluster administrator, you have been tasked and configuring permission to restrict pod-to-pod communication except explicitly allowed. Where can you define these permissions? Okay, let's look into the options. Option A, dynamic groups. Dynamic groups control IAM access for OCI resource, not pod level network communications in Kubernetes. So option A not a good answer. Moving on to option number B, RBAC rules. RBAC rules control access to Kubernetes resources, not network traffic between pods. So option B again a wrong choice. Moving on to option number C, network policies. Network policies explicitly control pod-to-pod communication, enforcing security boundaries within the clusters. So option C looking a good answer. Let's keep it. Moving on to option number D, IAM policies. IAM policies control access to OCI resources, not pod level communication within the Kubernetes clusters. So option D again a wrong choice. So option C will be the correct one.